So this is going to be, so after we do the class kick, you can come back to this, but this is going to be your checkpoint for your interview project. If you have done absolutely nothing on this, that means that in the next 24 hours, you get to do some of this work. If you have already started it, this should be super easy. So the first spot is like a rough draft of your budget. If you are done with your budget and it's already done and you already have like your pretty thing, then just take a screenshot and put it in here. If you have not done that budget, then by tomorrow morning, 8 a.m., you have to at least know some of that stuff. So you should at least narrow down where you plan to go, or where you're saying you plan to go, so that you can get those kinds of fees. It does not have to be perfect yet. Obviously, that would be later. But so if you weren't here, I went over a project. It's on there's a video of it. Yeah. You've got some work to do in the next 24 hours if you have no idea what I'm talking about. Yeah. All right. Then if you've completed your interview, then you can literally screenshot the answers to your questions and you can include them here. You don't have to retype anything or handwrite anything. This would be just screenshots. If you have not done your interview yet, then your answers should at least be in here, at least most of them. There's ones that say like, do you want to do the same thing as them? If you haven't done your interview, you won't know that. But the other ones should be here. Again, this can be a rough draft, but there needs to be something done here.
You have to multiply both.
Here. And then here's the screenshot of your 8-semester track, your plan of study. By now, you should have that answered because that is a you question. Even if you didn't do your interview, you should know what kind of major you're interested in. And then remember I said, this is the thing that I have seen people have the hardest time find, specifically the 8-semester track or something separated out, like a course of study separated out by semester. So if you need help with this, then you can let me know, and not the night before it's due, but you can let me know and I'll help you find this stuff. This is just to make sure you've gotten started. There's obviously much more to the project in addition to this, but you need to at least have gotten this started.
Is that the semester?
Semester is your whole major.
Okay.
The course description is just the math course.
For one semester?
No, it is all 8 semesters.
Oh.
Yeah. Huh?
Like 4 years.
4 years. Yep. This is due by 8 a.m. tomorrow. This checkpoint is due by 8 a.m. tomorrow morning, okay? But if you haven't started it, you're not doing that now. We're doing class kick. If you finish the class kick, then you can move into this. If not, this becomes something that you need to do at home. So all right, so the only thing from 9-4 that's not on this class kick is the graphing one. I feel like that's the one that was kind of the easiest, where you just had the T-chart, you had to fill it in. The next two questions, so question 1 and 2, these are both from 9.4. 9.4, okay? This one says eliminate the parameter. What does it mean by eliminate the parameter?
Solve one for T.
Good, you got to get rid of the T. So you're solving one of these equations for T, and then you're plugging it into the other one. And at the end, you should end up with just a y equals, and there should be no T in that equation.
Does it always have to be y equals, or can it be x equals?
It usually is y equals. I would say it's x equals if it's like a parabola turned on its side or something like that. Sometimes we do that, but other than that, it should be the y equals. On this question, there's two things that are happening that you just can't do. One is on this side, like I'm seeing people distribute this squared. You can't distribute a squared, okay? You have to expand and FOIL it. So this is two completely different ways to do it. On the left-hand side is if you solve for x, like you took the first one and you solved that for t and then plugged in the second one. On that, the mistake is not doing plus and minus. If you square root both sides of the equations, you have to put a plus and minus. So if you think about it, if I were to graph both of these, if I took this equation and graphed it, it's a square root and it's a plus and minus square root, which would be a square root turned on its side. That would look at a sideways parabola. This one is a y squared, which is also sideways parabola. So these should end up with the same type of shape, right? But you could have done it either way. If you did it on the left and you solve for y, that's fine. Just don't forget the plus and minus. If you did it on the right and you expand, don't forget to expand and FOIL. And then you want to be able to combine your like terms. So you should have been able to take it all the way to that last step. So I would have taken either answer there, the x equals or the y equals, depending on how you did it. The question 2 is also 9-4, and this time it's finding the parameter. So one of these equations has a t in it and one does not. You have to solve the equation that has the t for the other variable. So in this one, I would solve the bottom one for x and then take and plug it into the first one. And the answer for these is an x equals and a y equals, and they should both have t. Okay, so those are the two different kinds. Sorry? Yep. For question 2, you had to take the one that has the t, which is the x, solve it for the other variable. So I solve for x, and then take it and plug it into the x. That's this step. Distribute the 12, combine your like terms, and you get y equals 94 minus 24t. The answer for this question is both the x equals from the beginning and the y equals, and they both have to have the t in them. So that should have been the answer there. X equals 8 minus 2t, y equals 94 minus 24t. Obviously, the order doesn't matter, but the signs do. So if you switch them, just make sure the right signs with the right one. I'm going to let... All right, then questions 3 through 10 are all from 9-5. This was polar. So the first ones are just graphing. Okay, remember you're graphing these, you're going to the angle, and then you go out to whatever number ring it is. If the r is negative, you go the opposite direction. So these are two just graphing. All right, 5, 5, or 6 is there, and then move in the opposite direction. That should have been -2, 5, 5, or 6. God bless you. Question 4, which is also from 9.5, is finding 3 additional representations of the point between -2 pi and positive 2 pi. So this is, we either take r theta and we keep r, take theta, add and subtract even multiples of pi like 2 pi, or we do r theta and we change r's sign, take theta, add and subtract odd multiples of pi like pi or 3 pi if there's not enough from those. All right, question 4, you had to find 3 additional representations of that same point. If I kept r as positive, I could subtract 2 pi and you got -4 pi over 3. And then if I change r to be negative and subtract pi, I got -pi over 3, and change 4 pi to be positive or to be negative, and then add pi, and you get 5 pi over 3. Those are the 3 additional representations of the same point. Question 5 is from also 9.5. Now you're converting the point to rectangular. So I'm going from polar to rectangular. This is r cosine theta, r sine theta. Yep. 9.5 is the conversion, so it's 5 times the cosine of 2 pi over 3, and then 5 times the sine of 2 pi over 3. 2 pi over 3 has the coordinate point that's -1/2 and √3 over 2. So sine there, or sorry, cosine is -1/2, sine is √3 over 2. Simplify it and I get -5 over 2, and then 5 √3 over 2. Question 6, 9.5, is going from rectangular to polar. So r equals the square root of x squared plus y squared. And you do tan theta equals y over x. Figure out theta from there, and remember it's based on the original location. So theta based on quadrant from original point. Question 6, now you're going the other direction. So you had to find r. R should have been 4. When you square 2 √3, you get 4 times 3. You square -2, you get 4. Add those together, you get square root 16, which is 4. That's your r. And then -2 over 2 √3 becomes -1 over √3, or -√3 over 3. The tangent there is over 6. And because it is a positive x and a negative y, it's fourth quadrant, so it's 11 pi over 6. Question 7 is the same. We're back to rectangular. So this is the r cosine theta, r sine theta. Back to the other, going from rectangular to, polar to rectangular, this would be 4 cosine 7 pi over 6, or negative 4. Negative 4 sine 7 pi over 6, and you should get negative 2 root 2 and positive 2 root 2. This one is the same, r equals square root x squared plus y squared, and tan theta equals y over x. And then back again the other way, r this time is 8. And theta is 2 pi over 3. That's the over 3 in the second quadrant. And the last two are using the calculator. So this was what was not on your quiz, and this will be on your test. Your test is going to be separated into two parts. The calculator part would be something like this. So you can either do what we already did. If this is to rectangular, this is polar to rectangular. I can do r times the cosine of theta and r times the sine of theta. Or you go to the angle menu on your graphing utility, but it's got to be in, must be in polar and radians. And you can use your shortcut keys that are under your angle menu. So you would be doing polar to r, p to rx, and p to ry. And then the last, these were both calculator based. So if you use the shortcut on your calculator, you're doing r cosine, no, not the shortcut. If you do the regular one, r cosine theta and r sine theta, or you do the shortcut, which would be the p to rx and p to ry, you should get 2.97 and negative 1.33. Okay, to do this on the calculator, you have to make sure you're in radians and polar, and then we're going to go second to the apps menu where that angle is, and we're going, this time we're going from polar to rectangular. So I go polar to rectangular x, negative 3.25, comma, 2.72, and that's the x value, and then second apps, polar to rectangular y, and I do negative 3.25, comma, 2.72, and that's the y coordinate. One is again using a calculator. This is again 9.5, and this time we're going to polar. So you're doing r to p, and you can either use the little shortcuts r to p r and then r to p theta. Or you can do what you do where you do r equals the square root of x squared plus y squared, and tan of theta equals y over x. You can choose which ones you want to use there. Obviously, the shortcut keys are faster, but other than that, it's up to you. And then the other way, going from rectangular to polar, should have been 7.21 and negative 0.59. Okay, here's how to use the calculator to find these. So this one is from polar, or this is from rectangular to polar. So the first thing is your mode has to be in both radians and in polar. And then you're gonna go second, apps to the angle menu. And because we're going from rectangular to polar, we go r to PR. And then I type in that 6, comma, which is above the 7, negative 4. That's the r coordinate. And then we do the same thing, second apps. This time I go r p theta, 6, comma, negative 4, and this is the theta.